we are also interested in the inverse trigonometric functions. Now we've seen before that we can create an inverse by reflecting a function in the line y equals x, and we'll have a look at that for the trig functions just in a minute in the graphical calculator. But first of all, we'll write things down mathematically here. So let's say for example we had a function. Now rather than use the angle as x, we'll just use the angle theta. It's just to get away from continually using x all the time. So let's say we had some function of theta, and that function was sine theta. Then the inverse function f inverse of theta, so the -1 there means the inverse, so that's read f inverse of theta. So we write the inverse of the function as sine, and that little -1 with the theta is actually read inverse sine theta. So when you see this written here, read it as inverse sine theta. So you have to be careful, that doesn't say sine theta to the power of -1. Okay, that's nothing like that whatsoever. That is read inverse sine of theta. Now sometimes you'll see it written as arc sine theta. You see this written less and less now. It tends to be a little bit dated, but you'll still see it written in some textbooks. So we could write the inverse for each of the functions. So we could write inverse cos of theta or arc cos theta. You could write inverse sine of theta or arc sine theta, and you could write inverse tan of theta or arc tan theta. It's best seen by example. So if we had, say for example, sine of 60 degrees, well that is equal to root 3 upon 2. But now what we want to do is we want to go from the root 3 upon 2 and go back to the 60 degrees. So the way we write it is inverse sine of the root 3 upon 2 will give us the 60 degrees. So in terms of the cosine function, we would have cos of 45, which is 1 upon root 2. So therefore to go from the 1 upon root 2 back to the 45 degrees, we write it as inverse cos of 1 upon root 2 equals 45 degrees. And also if we were looked at, say, tan of 30 degrees, say that is 1 upon root 3, then in order to go for the 1 upon root 3 back to 30 degrees, we would write inverse tan of 1 upon root 3 equals 30, so quite self-explanatory. But what we'll do is we'll look at these in the graphical calculator and we'll actually put the values in, and I suggest you also get your calculator that you tend to use and make sure that you can type in the inverse of, say, inverse sine of root 3 upon 2, and you can get an answer of 60 degrees. So let's have a look at that now. So let's do the first one here. We looked at the sine of 60, so let's put in sine and we'll put in the 60 degrees, and that's going to give us 0.866. So that 0.866 is actually root 3 upon 2. So now if we want to do the inverse, we want to go from the 0.866 back to the 60 degrees, then in this particular calculator we've got the functions here, and you can see inverse sine, inverse cos and inverse tan. So again, if you look in your calculator, you'll probably see these inverse sine, cos and tan just sitting above the sine, cos and tan button, and you probably get access to the inverse by first of all pressing a shift button. So have a look in your particular calculator. So now what we want to do is we're going to do inverse sine, and I'll put it in just this here, so it's 0.866, 0.866, and this should give us back to the 60 degrees, and you can see 59.997, so that's the 60 degrees. Now you can do the same for the cosine example and the tan example, and they're exactly the same as I've done here, only I'm just using the cosine and the tan, so I won't bother going through those. So let's go and we'll have a look at the actual functions and see what the functions physically look like. So let's look at the inverse functions. Now we're not going to spend a lot of time in this, it's just to give you an indication of what they're like. So if this is the sine function, then we want to be able to reflect it on the line y equals x. So we're going to reflect this part of the line here on y equals x, And when we do that, we get this arcsine function, which is just the inverse sine. And this is the function here in red. Now we're not going to spend much time in this because we don't really need to bother about this at the moment. It's just to give an indication of what the functions look like. Now we could do the same for the cosine function. So that's the cosine function here. And again we can map it, or we can reflect it in the line y equals x, and we get that arc cos function. And that's the function seen in green here. And finally we can do the same with the tan function. So we've got our tan function here, and whenever we reflect it in the line y equals x, we get the arctan, and this is the arctan function here. So just as an indication here, if you went into, say for example, the sine function and the arcsine function, and we zoomed in a little bit and we just picked one point to show that it is actually an inverse, we could pick a point on this line here. So say for example 0.8, so 0.8, so we go along 0.8 and we go up 0.717. So if we go along 0.717 in the red one, we should go up 0.8. So let's do that. So we go along 0.717 in this 717, and we go up. You can see it's approximately 0.717, so we're going up 0.8. Okay, so you can see then that these functions are indeed inverses of one another. So that's us covered the work on the inverse trig functions. I'll get you on the next video. Goodbye.